Hello, this is question 2 from the 2009 maths. We have a list of real numbers x1, x2, x3, etc. defined by x1 is 1, x2 is 3. Then for n is greater than or equal to 3 by this, we got this sequence here, okay, where x3 will be related to x2 and x1 and so on. So x3 is 2x2 minus x1 plus 1, right? It's just shoving it in there, equals 6. Find the values for x4 and x5. So x4 is 2x3 minus x2 plus 1. X3 was 6, wasn't it? So we've got 12 minus, what was x2 is 3 plus 1. So that is equal to 10. x5 is 2x4 minus x3 plus 1. 2x4 is 20. x3 was 6, wasn't it? Minus 6 plus 1. So that equals 15. So that was a nice starter. Find values of real constants a, b, c such that for n equals 1, 2, 3, this relationship holds. xn is a plus bn plus cn squared. Okay, that's fine. We can just, let's change over to red so see we're on a different part of the question. x1, so for n is equal to 1, we've got x1, x1 is 1, isn't it? So I can just put 1 straight in, is equal to a plus b plus c. Okay, n is 2, x2 is 3, so that will be a plus 2b plus 4c. And then for n equals 3, we've got, that was 6, wasn't it? 6 is equal to a plus 3b plus 9c. So we just need to solve these simultaneously. So let's eliminate a's and b's and end up getting what c is, and then everything will be fine, won't it? So a is equal to 1 minus b minus c. So in the second one then, we've got that this is going to be 3 is equal to 1 minus b minus c plus 2b plus 4c. So that leaves that b is equal to 2 minus 3c. So that's the second one. Now we can stick all of that into this bottom one then. So 6 is equal to a, so that's 1 minus b, so 1 minus 2 plus 3c. That has given, what was I doing? A, 1 minus 2 plus 3c minus c, so that's a, plus 3b, so plus 6, and then minus 9c, and then plus 9c. So what does this give us for c? They cancel off. We've got 2c here, and then we've got 7 minus 2 is 5. So 6 is 5 plus 2c. So that means that c is a half, which means that b is equal to 2 minus 1.5. So that is a half. And a is equal to 1 minus a half minus a half, 0. So there we go. We found a, b, and c. Excellent. Go back to blue again. Assuming that equation star, so the thing we just worked out, holds true for all n is greater than or equal to 1. Right. Find the smallest n such that xn is greater than or equal to 800. Well, that's fine, isn't it? So xn, we've just worked out, well, a was 0, so we got a half n plus a half n squared. And we need that to be greater than or equal to 800. Okay, so greater than or equal to 800. So we can say, well, let's factorize these things then. So n plus 1, and then we can multiply by the 2. So greater than or equal to 1600. So, well, 1600 is 40 squared. So we're going to need, if n is 40, then we're fine. If n is 39, then we're not, because we'd have 39 times 40, which would be less than. If n is 40, we've got 40 times 41. So n is going to have to be greater than or equal to 40. Okie dokie. Part 4, last part. A second list of real numbers y1, y2, y3 is defined by y1 equals 1 and yn is yn minus 1 plus 2n. Find, explain in your reasoning, a formula for yn which holds for n is greater than or equal to 2. Right, so as usual with these, I like to get a flavour of what's happening in the sequence then. So we've got y1 is 1, y2 is going to be, so it will be y1, which is 1, plus 4. So that's 1 plus 4 equals 5. y3, and it can be useful writing out the sum because you can see what's actually happening then. So we're going to get y3 is y2, which is 1 plus 4, then plus 2n, so plus 6, which is 11. So y4, we can see what's happening here, 1 plus 4 plus 6 plus 8, which is 19. Right, so we've got an arithmetic sequence here, starting at 4, going up in 2s, plus we got this 1 as well, which is being tagged on. Well, it's like taking 1 off of an arithmetic series starting at 2 then, isn't it? So, because if that was a 2 at the beginning, we'd be saying is 2 plus 4 plus 6 plus 8. So yeah, let's do that then. So that means that yn is going to be equal to the sum of k equals 1 to, well, n of 2k. So we're just summing up all of those, and then we have to take, we do that, and then we'll just take 1 off, and that's going to give us what we want, isn't it? So right, what are we doing then? We're doing yeah, arithmetic sequence on all of this, because we're just adding on, and we're adding 2 each time. So what is our I always have to work this one out. I can never remember the sum to n for the arithmetic one. So it's half of the first one plus the last one multiplied by the number of terms, and the last one, so that's our n over 2, the last one in the sequence is n minus 1 times d plus a. So we've got n over 2, 2a plus n minus 1 times d. That's what I'm putting in for all of this. So this is going to be equal to n over 2, then multiplied by, so 2a is 4, plus n minus 1 times 2, and then I need to take 1 off at the end. So what have I got on all of this then? So that is 2n, then I've got n squared plus n squared, then I'm taking off n, and then I'm taking off 1. So that is coming out at n squared plus n minus 1. Right, that's yn. So that seems, does that actually match up? Let's just check this works with this. So when n is 2, we get 4 plus 2 minus 1 is 5. When n is 3, we get 9 plus 3 is 12 minus 1 is 11. When n is 4, we got 16 plus 4 is 20 minus 1 is 19. Right, so that certainly works. So that's given this. What is the approximate value of xn divided by yn for large values of n? So what was xn again? Xn is a half, let's write this, so xn divided by yn. Xn is a half of, can't remember what it was now. Oh, here we go, n squared plus n. Okay, so we've got that, and then we're dividing that by n squared plus n minus 1. Right, so as n goes to infinity, we're just going to be left with n squared over n squared. We're going to be left with a half. So xn over yn tends to 1/2. Nice. Okay, that was a pretty straightforward one, I would say. You can get some really tough questions on math papers, but I think that was one of the easier ones for starters, or maybe I just happened to latch on to the right way of doing things. But there was a definite pattern here that was quite easy to pick up in the sequence. I think this was the most difficult bit because at the start we're just plugging in numbers, then we're doing simultaneous equations, and this bit was pretty straightforward. I think, yeah, this last part was probably the most difficult part, but it was a fairly easy sequence in order to pick up on, I think, maybe, or maybe sometimes they just seem more obvious sometimes than others, and maybe this was just one of those. But I don't think that's a bad start to the paper.